Hmm. Hi dear students, welcome back to our channel. Today I would like to discuss the one sub new topic, that is collisions. Previously I am also discussed the unrelated topic. Main important lesson is work energy power, and we are going to another concept discussing the related topics of collisions. Now coming to the point is, let's start to the point is collisions. Define collisions and types of collisions, and also derive the equations of one dimensional elastic collision. Finally, after the relative velocities, final velocities v1 and v2, finding the straight line of path way. So first one is elastic collision. First one is collision statement. First one is statement definition. Collision's definition: a strong interaction between two bodies among their exchange of velocities or momentum. Exchange of momentum. The final change in momentum is known as collisions. That is delta P equal to mv minus mu. Delta P equals to mv minus mu. Therefore exchange of momentum. Exchange of momentum. Exchange of momentum. And fine. And next one is elastic collision. Types of collision. These collisions are two types. First one is elastic collision. Second one is inelastic collision. Now elastic collision. Elastic collision. Elastic collision is elastic collision. If two bodies, now we are taking two bodies A and B. These are maintainly some initial velocities u1 and u2, and after that final velocities v1 and v2. Definition of elastic collision. Definition of elastic collision: the collision in which both momentum and kinetic energy are conserved is called elastic collision. The collision in which both momentum and kinetic energy are conserved. Both momentum and conserved. That's momentum is P equals to mv and kinetic energy K equal to half mv square. These two are changes. That means one point to another point, these two quantities must be changes. Example of elastic collision is collision between two billiard balls. First one is collision between two billiard balls. Billiard balls and gas molecules. Collision between two billiard balls and gas molecules. Second example is, and also another example is, collision between nuclei and its target. Collision between nuclei and alpha particle. Target means alpha particle. Second one is. Now another point is inelastic collision. Inelastic inelastic collision. Now we can explain the phenomena of inelastic collision is taken to be the collision in which only momentum is conserved but not kinetic energy. Now I am taking to momentum. Momentum is conserved only one term. These two terms are available here, but only momentum is conserved but not kinetic energy. Only momentum is conserved but not kinetic energy. It must be changes. Momentum is changes but not kinetic energy. Only one quantity is changes. Example is collision between bullet and its target. Collision between bullet and its target. And second example is first one. Second example is a ball hits by a bat. A ball hitting by a bat or with the bat. Ball hitting with a bat. Enough. These 2 points are most important. Inelastic collision is taking to be collision between bullet. Main one is bullet and a target. These are 2 points, or 2 systems are separated by some distance. And now bullet entering to the wooden block or target, that's kinetic energy is maintained. Second one is ball hitting by a bat. We must observe in the cricket game. And also derivation of collisions or one-dimensional elastic collision is derivation of one-dimensional elastic collision is and we can explain the one-dimensional elastic collision. One-dimensional elastic collision. This one also taken to be head-on collision. Head-on collision. One-dimensional elastic collision or head-on collision. Most important. One-dimensional elastic collision. 8 marks question this. Most important. 4 marks and 8 marks. One-dimensional elastic collision or head-on collision. One-dimensional elastic collision means if two bodies are colliding to each other, their two bodies traveling after collision, these two bodies traveling along the same straight line path. Only momentum is exchanged, that bodies. That collision is known as one-dimensional elastic collision. One-dimensional elastic collision. If two bodies, now explain the two billiard balls are we must observe the carom board, coins, striker and coin, both are interacting to each other. Before collision, there will be meeting at a point. After collision, the two bodies or two balls are striker and coin. There are travels. They are travels along the same straight line path. That path is known as one-dimensional elastic collision or head-on collision. Let's most important concept of diagram is first one is first ball. This is first ball. This is second ball. Here first ball mass is m1, second ball mass is m2, and first ball is taken to be A, second ball is taken to be B. Here first ball initial velocity is u1 and second ball initial velocity is u2. These two bodies are colliding to at a point or interacting to the point. This one is before collision, the two bodies separating to each other. During collision, exchange their momentum and velocity. Momentum means P equal to mv, only velocities must be changes. First body is A, second body is B. During this collision, only velocities changes. And second one is after collision. First body is A, second body is B, center point. This one is center point, and after collision, final velocities v1. First body velocity v1, second body velocity v2. After collision, the two bodies velocities is v1 and v2, and masses are same, m1 and m2. Here masses is same, m1 and m2. The two bodies masses is same. Before collision and during collision and after collision. And proof or dimensional formula, that means after the velocities approaching two bodies before collision, after collision separation. Now calculate the velocities and the derivation. Applying law of conservation of momentum. Only don't discuss the only head-on collision. Head-on collision must be explained. The main principle is momentum and kinetic energy both are conserved. So these two formulas, two principles are applying in this phenomena of diagram. Applying law of conservation of momentum. Mainly balls of masses, two bodies masses m1 and m2. Initial velocities before collision u1 and u2, and final velocities v1 and v2. Bodies masses are same. After collisions, velocity v1 and v2 be calculated. So mainly law of conservation of momentum is explain the phenomena of principle is m1. Mainly formula is m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. And here main theme is u1 is greater than u2. Here condition is u1, first body velocity is increased than comparatively second body. Applying law of conservation of momentum, first one m1 u1, again m1 u1. This term, first term, this term is taken to be left side, this term is right side. So m1 u1 minus m1 v1 equal to m2 v2 minus m2 u2. Again m1 term is common term, u1 minus v1 equals to m2 is common term, v2 minus u2. V2 minus U2. This is equation number 1. And again applying law of conservation of kinetic energy. Applying law of kinetic energy, law of conservation of kinetic energy, law of conservation of kinetic energy, applying law of conservation of kinetic energy. Here this term, these two balls of masses M1 and M2 reliability. Conservation kinetic energy means of mv square. This first ball kinetic energy is of m1 u1 square and second body kinetic energy of m2 u2 square, and after collision body's kinetic energy is of m1 v1 square of m2 v2 square. Here total momentum, both are common term is total momentum before collision equal to total momentum after collision. In similar way of method, total momentum and kinetic energy. Total kinetic energy before collision equal to total kinetic energy after collision, that is of m1 first body mass m1 u1 square plus second body kinetic energy is of m2 u2 square equals to of m1 v1 square plus of this body kinetic energy, again this body kinetic energy of m2 v2 square. Again common term is of m1 u1 square, this term is taken to be left side, of m1 v1 square equals to of m2 v2 square minus this term is taken to be right side, of m2 u2 square, of m2 u2 square. Again common term is of m1 u1 square minus v1 square. Both these terms, only of m1 is common, and second one is of m2 v2 square minus u2 square. Both sides of get cancel, m1 get cancel, this term m1 get cancel, m2 sorry m2, this term is m2, this term is m1, this term is m2, this term is m1. Only of get cancel, of get cancel. This is equation number. Remaining term is m1 into u1 square minus v1 square, that equals to m2 into v2 square minus u2 square. This is equation number 2. This is equation number 2. Again this is equation number 1, this equation. Here term is equation number 2. Both 1 and 2 equations, dividing 1 and 2 equations, dividing equation 2 and dividing equation 2 with 1, first equation, dividing 2 equation with 1. Again that means second equation by first equation, second equation by first equation, this term, and again Dividing equation 2 by 1. Here it is second equation, first equation. Second equation by first equation is m1 into u1 square minus v1 square, that equals to m2 into v2 square minus u2 square. This is equation number 2 by first equation. First equation is this one, m1 into u1 minus v1 divided by m2 into v2 minus u2. Both term, numerator m1 and denominator m1 is get cancelled, m2 get cancelled, m2 get cancelled. Main explanation is velocities of bodies. Here in this equation, mathematical formula is involving a square minus b square. Mathematical formula applying a plus b into a minus b is term is a square minus b square. U1 square minus v1 square equals to u1 plus v1 into u1 minus v1 by u1 minus v1, and again v2 square minus u2 square can be written as v2 plus u2 into v2 minus u2 by v2 minus u2. u1 minus v1 and u1 minus v1, this term is cancelled, and remaining v2 minus u2 get cancelled. Remaining equation is therefore u1 plus v1 equals to u2 plus v2, and again u1 minus u2 equals to v2 minus v1. Mainly equation is this term. Here the relative velocity approaching before collision is equals to relative velocity after collision, u1 minus u2 equal to v2 minus v1. Now to find velocity after collision v1 and v2 and to find velocity v1, now another equation is taken to be first equation. This is first equation, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Now equation number from equation 3 is u1 plus v1 equal to u2 plus v2. To find velocity v1, and this term is v2 is calculated, v2 equal to u1 plus v1 minus u2. This is equation 4. Equation is substitute here in this equation, that is m1 u1 plus m2 u2 equal to m1 v1 plus m2 into v2 term is u1 plus v1 minus u2. Again substitute, that equal to m1 v1 plus m2 u1 plus m2 term is v1 into m2 u1 plus m2 v1. This term is v1. Again minus m2 u2. This one m1 u1 plus m2 u2. Again m1 u1 plus m2 u2 equal to m1 v1 plus m2 u1 plus m2 v1 m2 u2. Velocity is, this term is m1 v1 m2 v1, again m1 v1. These two terms are taken to be one side, and remaining term is remaining terms is taken to be either one side. m2 is common term, m2 and m1, v1 is common term, so v1 is this term, this equation m1 v1 plus m2 v1 equal to m1 u1 plus m2 u2 minus m2 u1, this term, again plus m2 u2 plus m2 u2. This one is common term, v1 is common, m1 plus m2, that equal to m1 u1 plus m2 u2. This term is m2 u2, again this term is m2 u2, 2m2 u2, again m1 u1 minus m2 u1 plus 2m2 u2, that equal to m1 u1 is common term, m1 minus m2 into u1 plus 2m2 u2, therefore v1 into m1 plus m2, therefore here v1 is based left side, that equal to m1 minus m2 by m1 plus m2 into u1 plus, this term is right side, denominator value 2 m2 by m1 plus m2 into u2. This is equation number, only this equation number 4. This is equation number 5, before 4th, this is equation 5. Again, to find velocity v1 is enough, and again to find velocity second is, and again to find velocity is v2 from equation 3, same from equation 3, here u1 plus v1 equal to u2 plus v2. To find velocity v1 and left side taken to be v1, from equation 3 v1 is calculated u2 plus v2 minus u1. This is equation number 6. This is equation number 6. 6 is substitute in this equation below equation. 6 is substitute in this equation below equation. m1 u1 plus m2 u2 equal to m1 v1 plus m2 into u1 plus v1. This equation is substitute given equation below, that is m1 v1, v1 is replaced by this term u2 plus v2 minus u1, and again plus m2 v2. Multiply this term m1 and remaining equation is m1 u2 plus m1 v2 minus m1 u1 plus m2 v2. Again m1 u1 plus m2 u2. This equation v1 and this equation v2. So this value is rough. and again m1 u1 plus m2 into u2 that equal to m1 u2. To find velocity v2, this v2 term, second v2 term and another term is v2. These two terms are taken to be one side. Remaining term is this one and this one. m1 u2 and this term m1 u2 minus m1 u1 plus m2 term is common, m1 v2 term is common, therefore v2 into m1 minus m2, v2 into m1 minus v2, m1 v2 common factor, m1 plus m2, m1 v2 common factor, m1 plus m2, again m1 u1 minus term, this term is taken to be left side, that is m2 u2 plus this term 2 m1 u1 minus m1 u2 equal to v2 into m1 plus m2, and again u2 is common value, therefore m2 minus m1 this term into u2 is common plus 2 m1 u1 equal to m1 plus m2 into v2, therefore v2 value is calculated. Velocity v2 means v2 equal to, here v2 ని బేస్ చేసి రాస్తే లెఫ్ట్ సైడ్ ఇట్లా రాస్తాను, సో m2 మైనస్ m1 ఇంటూ u2 ప్లస్ 2m1 u1 by m1 plus m2. Again, therefore v2 equal to m2 minus m1 into u2 by m1 plus m2, again this term plus 2m1 into u1 by m1 plus m2, this term. This is equation number v2. This is equation number 7. 6, equation number 6, 7, 5, equation 5 and equation 7 are v1 and v2 velocities. Thank you for watching this video. Thank you.